So, good afternoon to everyone who is joining us today. Welcome to all school students, teachers, parents from all around Malaysia, not forgetting all UMS students and staff present in this webinar session. Thank you, and we meet again for today's sessions of STEM Speaker Series or 3S. So, for your information, 3S is a collaboration between UScience UMS and my STEM Ambassador UMS. My name is Eda Shawati binti Dakim. I'm from UScience UMS as a science officer. Will be in charge as moderator for this session. So for those who join us for the first time, this STEM speaker series is a co-joint effort with Faculty of Food Science and Nutrition UMS. This program is fully supported by the Sabah Ministry of Science, Technology and Innovation, aimed to deliver unique and interesting STEM topics designed by subject matter experts to increase the interest of school students, teachers, and community alike to venture in the fields of STEM. For any question from the audience, please feel free to drop your question and on the chat box at the right side of this live session. Please be informed that for today's session, e-certificate will be given to school students and UMS students. Therefore, I would like everyone to stay tuned with us to fill the form given through link that will be shared at the end of this session. So before we started, I would like to introduce our speaker. With us today is a distinguished academician, Associate Professor Dr. Giap Weng. He is currently an Associate Professor at the Faculty of Computing and Informatics and also Director of Center for E-Learning UMS. Previously, he was in Faculty of Cognitive Science and Human Development and was the Director of Center of Excellence for Semantic Technology and Augmented Reality or COISTA in UNIMAS since 2007 to 2018. He obtained his PhD in Computer Science, Salford University, Manchester, UK, and BSc Hons Cognitive Science, UNIMAS. His expertise is in the area of augmented reality, AR, visual reality, VR, interactive technologies, and artificial intelligence, AI, blockchain, and also Internet of Things, IoT, and the use of AI to enhance training capability in the social, organizational, and ICT deployment in organizations. He has published more than 100 research papers in book chapters, journals, conference, policy papers, posters, newspaper articles, and newsletters. He been appointed as adjunct professor and also appointed as academic advisor in many institutions. He has secured more than 100 projects and consultation projects for teaching, R&D, and commercialization in the university or industries with total amount more than 10 million ringgit. He been appointed as paper reviewers in refer journals, international conferences and books, International Journal Editorial Board, co-chair in international conference, and as invited speaker and facilitator for many conference, research seminar, and workshop. He has successfully graduated many PhDs and master by research students. He also been appointed as internal and external postgraduate examiner. He has received more than 80 national and international awards from R&D projects and has secured more than 10 R&D intellectual property software copyrights patent filing. So without further ado, please welcome Prof. Giap Weng with his topics entitled Augmented Reality and Smart Agriculture. So Prof, please be invited.
Yeah, thank you very much, Miss. Check one. So for your brief introduction about myself. So good afternoon to all. Can hear my voice clearly or not? Hello, can hear my voice clearly?
Yeah.
Okay, can see my screen clearly also?
Your screen also clear.
Okay, good afternoon to all. So thank you very much for the chairman for introducing about myself, for my past experiences. So today I would like to present, I would like to let everyone know how the latest technology incorporate into the so-called agriculture. So today topic, we are going to discuss about augmented reality and the smart agriculture. So everyone will ask about what does it mean by one of the so-called the video here, that how this AR came into this picture together. So when you are in the forest or you are in the adventure, yeah, so you are wearing a special glass like this. So the glass itself will show you the overlay information about the artifacts. From the glass itself, you can see that the 3D object will pop out, and overlay onto your screen here that you will see and also interact with the object itself. Yeah. So from here, we also can immediately send the information from the forest to the lab. Then you will see exactly what information that you needed from the lab itself. Not only that, this technology, if you are assuming you are wearing a special contact lens, then you can see the overlay information on the table. Then also this technology will also recognize your face, that how it works for the future generation. Yeah. So not only that, when you are wearing a special contact lens like this uncle and auntie, so you can see the overlay information about the food, food and fruits nutrition will pop up on the screen itself as well. So you can see from here that all the information that related to the that are available in the fridge. So you can see clearly what are the things that still available, and the store itself, the stock itself still available. So not only that, in the education as well, you can see the virtual teacher pop up right in front of you. And also it can be used into the manufacturing, logistic, and education, and so on. Yeah. So not only that, the agriculture as well. So also can be into the vertical farming, logistic, and so on. Yeah. So later on, I will talk more about how this AR technology can be used into the agriculture field of studies. Yeah. Okay. So you can see from here that how this technology can be used and also can be controlled using this technology into different areas of the so-called agriculture. Can be the using into the farming, can be using in the vegetable, can be using into the cow farm, or and so on. Yeah. So not only that, you can see this how the vision and mission of the so-called agro that promotes innovation through cutting edge technology, the economic value return. This is mean that how technology can improve and enhance the profits and the economic value, and also can enhance the life of the people in near future. So the mission of it is so-called how are we going to support the powerful agro business and the technology venture through the capacity building and the facilitating access to the knowledge and resources itself. So from here, you can see that the latest technology of the agriculture can fully utilize into the agriculture, can make it more advanced and easy for the farmers, and also for the people that who want to involve into the so-called agriculture field point of view. Yeah. So you can see from here that what we are going to look into it, how agriculture can work on. So you can see from here the icon that we stated here, display here in this slide itself. You can see that the agriculture itself not only consists of the so-called drone. We also can be considered as a biotech, halal, e-commerce, and also the so-called ICT and IoT agriculture. And one of the field that today we are going to discuss is the so-called augmented reality and also the smart agriculture. So there are many fields, available in the agriculture, but today we are only concentrating into AR technology. There are also other fields like the ICT and IoT in agriculture, and also the vertical farming and farming mechanicalization. So also the animal. So you can see from here that there are too many fields that we need to focus into the agriculture, but today only AR technology. So that you can see how the AR works, how AR works in the different areas. And at the end, later on, I will show you how AR can be into agriculture. So let me explain to you, when you are in the one of the library in overseas, for example, in German, in France, or in Japanese, in Japan, yeah. So, but you didn't know their language, for example, or when you are reading a books that you didn't know what does it mean for the language itself. So with this technology, when you are wearing a special glass or a special glass we call as a AR glass here, when the glass are activated, when the glass activated, when you look at the book itself on the glass, you can see the 3D will pop up. The 3D menu will pop up on the screen. Then even you can integrate and also you can interact with the book itself virtually. Then even that you also can watch the movie on the book, and also you can see more detail related to the contents that are available in the book itself. Not only that you can transform the 3D drawing into the book, that the overlay 3D object on the book itself, that it will be this thing that you can see. When you are outside from the building, for example, you can see overlay information on the building itself that stated the name of the building and the name of the building, and also what are the so-called the building meaningful. All kinds of information related the building will be pop up on the screen itself for you to recognize, for you to understand. This will be the thing that you can see how the so-called AR can be used into the field itself. So I think all of you also watched the movie so-called Iron Man. Now you can see the Iron Man, the eyes itself, the iris itself is looking at the screen that all the information will pop up. This is something that the futuristic technology that already put it into the video, into the movie called as Iron Man. So what we need for the implementation plan, especially for the agriculture itself, we need a very special smart farming implementation plan whereby we need the three major things. Which are manpower, production, and technology. Even though if we have the manpower, we don't have the technology, it doesn't work. Okay, if we have the so-called the manpower, we have the production, we don't have the technology, also cannot work out. So all three things can need to be combined. So only that you can work out the so-called the perfect plan, implementation plan for the so-called smart farming itself. Okay. So another video that I would like to show you here is how the so-called technology can be incorporated into the different different lifestyle here. You can see from here that if you are in the bus, I let you know what does it mean by AR first. Only then I will get into the AR in agriculture. So when you are in the bus itself, that you are wearing a special glass, you are playing a virtual game using your hand. And even you can virtually talk to your friend live on the screen. And also you can use this one to call, to chat, to play games, and also all the advertisement will pop up on the screen, something like this. This will be the future world of you after next 10 to 20 years later on. So meaning that when you are looking at it, you are sitting in the bus, then all the related information, advertisement, and all kinds of the so-called whatever information that you needed will be popping out, will be overlay on the screen that you are looking at. And also you are manipulating with your hand to gather interaction into the environment itself. So you can see from here that these are the latest things that you are going to look into in future, how great of the design, how great of the development, and how great of the arts itself, and also the content, instructional content and related information that will be incorporated together into the world with the technology. So when you walk out from the bus itself, all these advertisements are overlay on the screen. So you can see from here that all the environment, it looks like virtual, but you are into the real world itself. You are into the real world. This will be the so-called the information that you have to look at. Then also all kinds of the so-called related information from here that will guide you through where you are going to, and also you can be used in the shopping mall as well for any fruits and foods content related to the nutrition, and also the contents of the food and fruit itself that you want to purchase. So this is the video that I would like to closer and closer into the smart agriculture now. So you can see from here that if in order to achieve the smart agriculture, we need to have six things that we need to consider. One is the sensing technology, software application, okay, communication system, telemagnetic and positioning technology, hardware and software system, and data analytics. So these six components will be combined into one, then we call into the so-called smart farming itself, smart agriculture itself. Without one of the component, it doesn't work. Without one of the component, all the whole thing smart agriculture cannot work out itself. So you can see from here that how the technology going to come in. For example, we are incorporating and we are working together with the Industries 4.0. One of it is a smart agriculture. Because a smart agriculture can combine with the 3D, combine with the AR, combine with something else that related to this technology itself. Yeah. So you can from here that when we have the so-called greenhouse, something like this. For the common practice, we will have the so-called the software or the devices or IoT, Internet of Things devices like the sensors, cameras, Wi-Fi, or the equipment control. All those things will be incorporated. Will be installed into those so-called this greenhouse. Okay, this is still considered a very conventional, very common practice, common design of the so-called we call as a smart agriculture. But with this, you can see slowly it will be turned into the different types of the intelligent components, such as informatic analysis will be coming in to analyze the vegetable development and growing. And also we do have the fault alarm analysis, remote device control, decision and policy support. So this will be the real-time surveillance system that from the common installation itself to be into the real-time surveillance, more advanced features of the so-called agriculture we call it as an intelligent agriculture, because of we do have the extra layers such as a sensor, transmission, processing, and application itself. So you can see that from the very common and from the very basic installation to the real-time surveillance, we call it as an intelligent agriculture, that will be turned into the more advanced feature we call it as a augmented reality smart agriculture itself. Okay, let me show you the how the AR can be used in the what I call it in the agriculture itself. You are wearing a special glass, something like this, something like this. From the special glass itself, you have the so-called camera will overlay the information on the screen. So all the information on the screen will be stored into the cloud system, will be cloud database system, that whereby the processing part as well as the so-called the intelligent part, all everything will be into the cloud server. Okay, you can see the graph itself will be the dynamic live data set that stream from the data of the cloud system into your glass itself. So meaning to say that if you do have such sensor around your whole problem or each area, the farm that you need to more focus and also more taking care of the so-called that particular area itself. So this information will pop out only when you are looking on the so-called special glass, because the area itself is too big. And even the area itself is too long or too big, then all these things, the sensor will help each of the plant that you install. So you can see from here that from the installation itself, you can indicate, you can see the temperature, the pH of the level, okay, the nutrition, as well as the water. Everything will be on the screen itself, will be on the screen from the server stream to your glass itself. Not only that, the 3D object also can be streamed from the server on. Then you can see the 3D object will pop up on the screen, that you can see clearly how you can see clearly how the information will pop out from the screen, then to indicate you which plant that you need to take in care, which plant that you need to make sure that it is still alive and also still strong enough, healthy enough to continue for this journey. So not only that, with this indication, with this technology, you can have the live session of the training, together with the so-called with the expert itself from other country, whereby you can immediately to change or to maintain and also to do such maintenance for the agriculture machineries immediately. No need for the expert to fly over to indicate or to make the repair on the machine that you have. So this will be this another part of the technology that we are looking into. You can see from here that the expert is in another country, but the so-called another one is in at the farm. So actually to your needs and requirement itself. So with this kind of the thing here, you can see from here that all kinds of information that you store, it need to have the so-called information, so-called the instructional design related to the information need to be properly designed, properly designed, and also properly doing some study, only that put it into the right position and the right content into the system, so that when the user using it, when the user study it, it will show the correct information that related to the field that you study. So you can see from here that all the information on this video itself is the so-called real time. Then when you want to check whether the products that you look at it, whether it is healthy or not, whether which plant is still alive, or maybe which plant is need more attention on it, or you can see all the information related to each of the plant that display on the screen. You can see from here, this is a real plant, but on the screen of the augmented reality, you can see all the indication of the nutrition, all the water level, freshness, and the temperature will be displayed on the screen according to the sensor that been installed and streamed from the server, itself. All right. So you can see from here the smart agriculture, we do have the so-called related information. All kinds of information that we can put it in. So it depends on what information that we needed. Okay, what information that we needed, and also which sensor that we want to plug it in and also install into your farm. If your farm is very big, can consist of 1,000 or 2,000 acres, for example, for instance, you still can use this AR technology to control the whole areas of your agriculture itself. So not only that, you can see from here, in order to achieve this kind of the AR in agriculture, we need the so-called the latest features of technology, such as machine learning, artificial intelligence, or the deep learning to come in, that so that everything will be controlled, also can detect necessarily and identify the necessary information that is displayed on the screen itself here. So from here, you can see that how we trying to put all kinds of digitalization of the agriculture into the picture itself. Even though the areas itself, the whole areas of farming is very big, but we still manage to control everything into in your fingertips, itself. So from here, you can see that we not only can display the information related to the plant itself from the sensor, but we also can put extra information that related to the plant. The information that related to the plant, such as the history, the biology, and the background of the information of the plant, and also the location, and also the genetic of the plant. Everything will be put it into the data set, for example. So everything will be all kinds of things will be controlled with the nice instructional and proper instructional content design. So this will be the so-called collaboration in between the all different types of experts that come in to make it happen together. So meaning to say that it's not only one field of the AR expert to come in, but we need the instructional content design, we need the farmer, we need the expertise related to expertise, and also we need the so-called designer, graphic designer, and also some other tester to come in together to make it happen for this application itself. All right. So a key challenge is making the technology adaptable to the needs of the farmer regardless of the operational scale. With this statement itself, we can see that no matter how big your area, so no matter how big your area, so you can see that, however, in order to truly facilitate digital farming, the fundamental questions that must always be addressed is why. Why we need this technology? Because sometimes the area is too big, and there are the so-called different types of the so-called crops and also the plants or whatever that we cannot handle individually. So with the control, with the new technology available in the market currently, we can have the so-called combination of IoT, combination of big data, combination of the so-called the farm knowledge, as well as machineries and the mechanical engineering. All those things will be combined into one to make it happen. Yeah. So this will be the so-called digitalization of the so-called technology itself. So you can see from here that the greenhouse can be very, very big itself. The greenhouse can be very, very big. But with this kind of the greenhouse, we can turn it into the vertical farming, and also different types of the farming currently available in the world already. Yeah. So we can turn the so-called factory to be the farming as well. But with this kind of the technology itself, we need a proper technology to be into the factory. Then everything will be controlled by the technology, such as you can see from here, using the LED light to control the temperature of the so-called the whole area of the environment. All right. So with the so-called the water pH, also you can control the level of water, which kind of the content nutrition that we need to put it into the environment itself. Yeah. So you can see from here, one A shape also can. You can see from here the different design of the so-called agriculture itself. We also can use technology to be installed into that particular thing, even though it's different types of the setting. Yeah. So from here, from the very big environment, for the big scale of the so-called greenhouse, we can turn it into the small scale of the greenhouse, such as using the container. Yeah. Using the 40-feet container to control the farming as well. So you can see from here that even though don't think that container cannot be used for farming, but nowadays people tend to use container for farming, for hatchery, for something else as well. So you can see using this kind of thing, that using the LED light to control the environment with all kinds of sensor installed into the container, that we can monitor. We can monitor the so-called the pH, as well as the temperature, the atmosphere, and also the wind and the water filter, as well as the sprinkler to be installed into the so-called the container environment. So this is the so-called the setting up of the container farming as well, all installed with the AR technology, all installed in the latest technology and incorporate with the AR technology, that you can see each of the plant growing fast, growing healthily, and also growing perfectly for your output itself later on. Yeah. Not only that, from the big scale to the container scale, now later on we put it into the so-called the racking scale here. Racking scale means that this rack system itself, you can use your mobile phone to control this rack with your vegetable itself. Meaning to say that you can put this rack into your house, then also can put it into the restaurant, your kitchen, and also into the hotel, anywhere that you prefer with. The scale itself, you can, depending on your requirement and needs, and also depending on your design as well. Yeah. So you can foresee that this is not easy to do if we don't have this proper design for the integration of the technology with the so-called the knowledge of the farming, knowledge of the agriculture from the farmer itself. For example, for instance, how much the nutrition that we needed for the vegetable. How about the so-called the temperature that we needed for the leaf, or maybe for the plant, and so on. So we must have the so-called the knowledge of the farming, then that's why we cannot stand alone for the designing such a racking system using the technology to you can see that in the world in the 2050 so we will have 10 billions of people. Currently we have 7 point something billion people in the world. When achieved in the year 2050 we will have 10 billion, but with 10 billions of people we need more food to consume. Okay, so not only the vegetable itself, we also need more meat to consume as well for the world population. So with this kind of the figure, with this kind of figure itself, we are facing very, very high challenges. How are we going to produce with the limited space, with the limited land, with the keep on increasing the population of the world itself. So we need to consider how to use technology to reduce everything for this case. So in order to know about this as well, we need to know that if we want to open out the so-called the industry and for the agriculture, we need to have the so-called 25% of the farmland. So need to clean out the forest. Then only that we can have the so-called the factory available to do for farming or the farming areas itself. So in order to achieve that, we need a huge investment to come in to do so. So you can see from here that in order for this case itself, another thing is the climate change is reducing productivity in agriculture because we keep on cutting out the forests. We keep on cutting out the forests because we want to do for agriculture, but we didn't we didn't care about the climate. So this will cause the climate keep on reducing the productivity because the quality of the land, the quality of the climate keep on changing until we cannot control the whole environment, the whole structure itself to be in. Okay, so from here you can see that the climate change, people remain extremely poor because we don't have enough food to consume. Then you can see 800 million of people face chronic hunger because not enough food as well. So you can see suffer from the micronutrient for this case because the food itself not really healthy, not really fresh enough to control to let the more people to consume it, more people to enjoy the fresh food for their daily life. So in order to do such of the arrangement preparation for the future itself, you can see from here that the map of the technology and maturity of the technology need to consider each time from the time to time itself. From here itself, you can see from the current state of art of the technology, we are using the hydroponic, bioplastic, and the algae feedstock. So not only that, currently we also using the vertical and urban farming. But this another one, currently we also using the drone technology, Internet of Things, or blah, blah, blah. So you can see these are the things that we need to know that these areas is the so-called current situation, the state of art, the technology in the agriculture. What we need to think of is the next area or the maturity of the technology to reduce to reduce the hunger of the people and to increase the food and to get the people to have a better food and the freshness of the food and the good quality of the food for the people and the population in the world, that we need to consider how to use the desert agriculture, sea water farming, and so on. So not only that, we need to consider the genetic modification, also need to have the so-called 3D printing and the cultured meat. So this will be the coming in. So people tend to ask, what does it mean by 3D printing? In future, we can use a 3D printing to print out your meat, to print out the food that you want, or even to print out the fruits that we want to consider as well. So this 3D printing can be into the picture for the future, whereby we can produce the 3D food for this case itself. So not only that, in future, we need to consider nanotechnology, artificial intelligence, blockchain, and other foods sharing and the crowd farming itself. So this will be the so-called the direction and maturity of the technology for the next 10 to 20 years, even more than that. Even more than that. So for your information as well, that if we are using the so-called the intelligence system and also the technology, we can reduce, we can save water consumption, electricity, fertilizer, pesticide and also the labor cost. These are the so-called the study been done before. So you can see from here that how the technology could help into our smart agriculture itself. Yeah. So for the some data for you all as a reference, some data for you all as a reference, whereby you can see from here that if we are using conventional way of farming, you can see that if the chili mera itself, you from the 10,000 from the 10,000 kilogram per acre will increase to the 16,000 kilogram per acre. So same goes to the sawi as well, 6,200 increase until 49,000 plus. So lecture as well, also the same thing, increase huge. So you can see from here this kind of the technology, if we can use it properly, then it can help to for the future, especially the increase of the population of the in the world. So you can see from here that the vertical farming itself, from the conventional farming itself, from the 140 gram, then we will increase to 1,120 gram per square feet. So you can see from here that at the end of it, increase drastically if we are using the so-called the proper technology and also proper setting of the agriculture. Okay, so for the sustainability itself, you can see that if we are using the technology itself, we can save the environment, especially the climate change of the environment, so that we no need keep on cutting out the tree, keep on removing the forest. And also not only that, we can help the people and for the social well-being, and also to have a better food, quality food, and also to have enough food for the people. So not only that, it also can increase the profit for the farmer, increase for the profit for the entrepreneur as well. Yeah. So the stakeholder that are going to enjoy the so-called the whole circle of the smart agriculture could be from the government, retailer, and supplier, university, all those community and all those groups. So you can see the stakeholder all the stakeholders will enjoy the latest technology that put it into the agriculture field. Yeah. So from here you can see that from the overall outcomes and also the impact of the technology from the AR technology from into the agriculture itself, you can see that it will have the globe creation. Why I say so? Because in order to build the AR technology, we need the people to do so. Few groups of people to do so. So this will increase job creation as well. Not only that, we also need the education for this, because we need to train more people to look into this field and also to come up with a proper and also nicer technology for the agriculture itself. And we can turn the agriculture into the education, and also we can turn agriculture into the tourism. So from here as well, we can increase the export. We can taking care of the environment, and also can have the sufficient food supplies, and also clean and safe food, because we are using technology to control. You can see just now one of the slides shown that the doing the agriculture in the factory that properly controlled with the proper environment itself. Yeah. So not only that, we can have the affordable food price, because the more production of the food and the fruits itself, it will reduce the price in the market, for example. Yeah. So I think that's all from me. If you do have any questions, you can ask, and you can raise up your hand to ask for the moderator. Thank you very much.
Hello.
Yeah.
Dah lah, tunggu pun sulit jalan sebab dia bilang saya pun pening lah dia tiba-tiba ubah bang. Jadi kakak mau perlu meteorologi ni mau tukar.
Thank you very much, Prof. Weng. It was
Yeah,
a
thank
very
you.
interesting and wonderful topic, and very well presented. So we invited for some question to be answered by our speaker that was sent to us during the presentation. So is there any question from the audience?
Ada soalan kah?
Hmm. Soalan. Still any question, everyone? Sebentar ada soalan. Okay. So if there's no question, we can end our session for today. So the link for registration and e-certificate is now being shared for school students and UMS students. Please fill in your details and answer the simple feedback questionnaire. And all students will receive e-certificate while SDP point will be given to UMS students only. IDP's point also will be given to the UMS staff. So thank you again to Prof. Giap Weng for the time to share with us. And thank you to all the audience for your participation. We look forward to seeing you in the next STEM speaker series. Do not forget to follow us on Facebook and Instagram to keep you updated on the next session. It was a pleasure to have all of you with us on this beautiful day. With this, we conclude our webinar. Thank you for the cooperation and see you again.
See you. Thank you,
Okay,
Ms.
thank you,
Chairman.
Prof.
Have a nice day. Thank you,
Nice
everyone.
days.
Thank you, Doctor.
Yeah, thank you. Bye.
Thank you very much.